So this is the outline of the CPU. We have the ROM, which is the only easy way to paste in code. We have the program counter, so that you can actually switch instructions. And this is for the jump command, which can only read 4 bits from the CPU. Then we have the clock. We have a register out here for storing variables. Then we can read and output in decimal if from 0 to 9. If we go into the CPU, it's messy. I need my mouse. So it's a mess, but it works. Wasn't exactly meant to be looked at, unfortunately. But if we start off here, these are the inputs. This is the main input. It'll be for instructions so that you can have functions with the CPU. That's what these top 4 bits are for. These bottom 4 bits are for just numbers to be inputted into the instruction register or into the variable register over here. And you can load from the variable register over here, which you'll have to activate this to switch it, to switch which bits can get through on the bottom. Then we have the clock input. Actually, it'll be easier if I just do that. We have the clock so that it activates every so often. We have overflow and zero so that we can do jump commands. They go into the control unit right here so that we can check. But this main line is to transmit data into the instruction register or the control unit. The bottom 4 bits will go into the instruction register. The top 4 will go into the control unit. Then, unfortunately, it's a mess, but I need that to hook up there. We'll just go ahead and hook it up. On default, you'll read from the register, but that can change. But the control unit has all the outputs hooked up to the ALU, the actual instruction register, so that it can store data. And yeah, we have this register, it's the accumulator register, so that every time an output goes through the ALU, it is saved, but it can only save one number, so it gets stored over every time you do an operation and store it. This is the display, so that you don't just constantly display whatever you're doing, because that gets messy. So then you can set, or whenever you want it to refresh. We have jump data, which is essentially the register you want to jump to, or the register address you want to jump to. Then we have, is this pulse not hooked up to anything? Okay, leave it in case it is important. It's just glitching. In this is so that whenever you do clear accumulator, whenever you want to start a program, it just stores, but it sets it to that all inputs are 0. In the ALU, I don't care about the changes, it's already groups. In the ALU, we have all the functions you can do. None deactivates all the SR latches. The SR latches are here so that you can activate a like addition, subtraction, or any of the bitwise logic, and have it keep going for the next step and any steps after that, so you don't have to do it every other instruction. But if they weren't all hooked up into these OR gates, you could have add and XOR on the same time, and they would just make this flash repeatedly and break the code. So they deactivate each other. So if you multiple on at once, nothing will be outputted. This is the bottom 4 input bits. These are the top 4 input bits. When these XOR gates are activated, it inverts the signal so that if there's a carry, you can do subtraction with an adder. I don't know why I called these opcode. I'm gonna need to rename that. But these are essentially tri-state buffers so that you don't get an output when you don't want it. And these tests if, let's say, all the bits are overused. So like, let's say 15 plus 1, it activates it because it goes over and it would carry into a bit right here, but we can't output 5 bits. So we do an overflow, and that allows for conditional jumping. The 0 is for, like, let's say 8 minus 8. Oh wait, that was 8. Then it equals 0 so that you can do conditional jumping in loops that I'll show later. Then down here, the NOT gate just inverts every signal. So, because you can't really not 8 signals and turn it into 4. So it just does all of them and has its own output. Works better like that. Trying to chip. All these gates are wired up like this with 4 of their gates in the middle. Then the opcode is just a bunch of, well, these are just a bunch of 1 opcodes, but it's just a bunch of tri-state buffers. The adder is they're daisy chained to carry their input into the carry in of each of the full adders, which are made up of 2 XOR gates, 2 AND gates, and 1 OR gate, so that if you have 2 inputs, so that it can actually add. I don't know how to explain adding simply without something to draw on. Then up here is, what is the floor? It's weird. And do some stuff that I planned on doing. So now we move to the registers, and they're made up of D latches so that you can input data and store it, and it does set it to a random output because of the way these NOR gates are set up, but you can get Q, negative Q, so you can test if it's on or off. This master-slave register is made of master-slave D latches, which are 2 D latches hooked together so that the data is the output of the first one, so that it only activates on the rising edge of a clock. So if I were to open it and open this, you can do data, but nothing happens. You rise, but even if you change it now, it won't change. The clock has to go to 0 and rise up to 1 again to change. So that's how the registers work. This one is just made so that whenever you activate data with the store signal on, it'll just save it. So you could spam it. Like, let's say we activate that. and the clock. It just changes. But if you wanted to save to the accumulator register, you have to turn it on and off each time. So you actually can't line up two saves to accumulators to the accumulator. You have to do something else in between so that it deactivates. Which is unfortunate, but it works. If we go back out to the computer, you'll see the 0 and overflow run right back into the computer. Goes into the control unit so we can test for it. We have this variable register. Added it recently so that, well, I was hoping you could do multiplication, but I ran out of commands, so I can't have store from AC. I'd rather just be able to set variables easier. 7-segment, but I'm gonna change that into this decimal display whenever I finish it. But it's made up of all these and the double dabble, which is very annoying to make. It essentially shifts bits to the right from your input. Then if every 4 bits is essentially box, and if those 4 bits add up to above 4, so 5 or above, it'll add 3 to it, then it'll keep going. And that's made up of this setup, which is not fun to figure out. Then 7 segments, it's just a huge decoder, which is directly outputted into everything they do. So just trial and error is what I did. But it can count and all that. You have the double dabble. Other than that, that's pretty much it for the computer, but well, let's say you want to program it. And in Python, I coded this horror of code that, while it works, it is very unoptimized. But it converts all of these. I just forgot to remove that. It changes all these into code, and these are the opcodes. These are all the operations you can do that have no arguments. These are the ones you have with arguments. And this strips all the comments you have that you put in for your code. Horror.
What?
Horror. HORROR.
Okay, sound like you said four.
I'm not gonna cuss on a video.
What did you after that? So you can say it again.
Alright, it's almost done. But we have an example code, which when converted, what? Oh no, that wasn't what I thought it was. I thought that was the literal store variable. I gotta rerun it. I had a thing where you could put in store variable, so it'd store from AC, but I hadn't actually put it into the computer yet. But now this should work. It'll give you the binary code for the computer, the hex, and decimal. And if you want to, you can code it. It all has to be capital. But one funny thing about clear is it does 2 commands because it needs 2 clear commands to actually clear the AC. But let's say you want to do 5 plus 2. You would clear, set it to add mode, load, 5, then you would store it, then you would load to store it, then you will display. Now if you convert that, you get this, which if you copy, you can then come in here, paste, confirm, then we have to wait till this goes through all the stuff. Right now it's actually doing random because just started it up. So we'll set it to 1,000. Fine. Why is it doing that? Oh, I got places I don't know what I wrote. It's wrote the chunk because I can use it. It goes through super quick, and we'll do the code or not. I guess it just doesn't work right now. I'll fix that, but that's the computer. Bye.